Chapter Review 2, question number 7. The times it took a random sample of runners to complete a race are summarized in the table. Use interpolation to estimate the interquartile range. So for interpolation, the first thing we need is the cumulative frequency. So let's write the cumulative frequency here. 5, 15, 51, 71 and 80. So we need to find the interquartile range. For that we need the first quartile Q1, that is n by 4. Total frequency is 80. 80 by 4, that is equal to 20. We also need Q3, which is the upper quartile, and that is 3 by 4n. So that's going to be 3 by 4 of 80, which is equal to 60. So the 20th frequency comes in the third class interval. So the third class interval, we see the endpoints as 39.5 and 49.5. So let's draw the line for interpolation. 39.5 and 49.5. The frequency up till the third class and at the end of the third class will be 15 and 51. 15 and 51. So this is the cumulative frequency and this is the class interval, and we need to find the 20th value. So it's here, and that's Q1. Likewise for Q3, we have to find the value corresponding to the 60th frequency. So the 60th frequency will be in the fourth class interval. So we check the endpoints of the fourth class interval. Since it's continuous data, it's going to be 49.5 and 59.5. So 49.5 and 59.5, we are looking for the value Q2, and the class interval up till and after the at the end of the fourth class interval is 51 and 71. So 51 and 71, and we are looking for the 60th value. So let's do the working for the calculation. Q1 minus 39.5 divided by 49.5 minus 39.5, that is equal to 20 minus 15 divided by 51 minus 15. Likewise Q3, it's not Q2, Q3 minus 49.5 divided by 59.5 minus 49.5 is equal to 60 minus 51 divided by 71 minus 51. So we get the value of Q1 after calculation 40.9, and that is to 3 significant figures, and the value of Q3 as 54. Therefore the interquartile range IQR will be the upper quartile minus the lower quartile, which is equal to 54 minus 49.5, and that is 13.1. The next question, part B. The midpoint of each class was represented by X and its corresponding frequency was given by F. So we have sigma fx here, which is the midpoint into the frequency, add the midpoint into the frequency. and we have the squares multiplied by the frequency, which means we take the midpoint here, 20 plus 29. So the midpoint will be 20 plus 29 divided by 2. 20 plus 29 divided by 2, that will be 24.5. For example, we have 24.5. So for sigma fx, we do 24.5 into 5. And then we find the midpoint here, and then we multiply it by 10. So on and so forth, that give us sigma fx. For sigma fx square, we square this value and multiply it by 5. Then we square the next mid-x value and multiply it by 10 and keep on adding. So now we need to find the estimate of the variance and standard deviation. So first let's find the variance, and variance is mean of the squares minus square of the mean. So we already have the squares here. We just need to take the mean of these. So 183,040 divided by 80. So this is the mean of the squares minus the square of the mean. So the mean we can find by dividing this by 80, which is sigma fx. So 3740 divided by 80, the whole squared, and hence we call it the mean. This is, we are dividing 80 and these are the squares, so the mean of the squares and the square of the mean, and we get the value as 102 to 3 significant figures. Now we need to find the standard deviation, and standard deviation is nothing but the square root of variance. So that is going to be square root of 102, which is 10.1.